Welcome all of you. Welcome to ANIMATHS once again. In today's video, we are going to do areas of triangles. So we'll take different types of triangles. Okay, so we shall be taking a right angle triangle or any general triangle, a scalene triangle, or an isosceles triangle, or even an equilateral triangle. So we shall be learning how to find the areas of these triangles. But what is most important in today's video is we shall be learning the use of Heron's formula. Okay, so Heron's formula is one formula that you haven't learned anywhere till now. Okay, so we shall be doing this formula, which is a new one, but then as you proceed with the video, as you watch the video, you will see that I am solving Heron's by a particular method. Okay, it is not that if you know the values you can substitute and you can get your sum correct. Okay, so I am solving by a particular method by which you can work out the sum more easily and more correctly. In most of the cases you get you start getting your sum correct all the time by this method. It is a very fast process and a very easy process. Okay, so let us see what the sums are. Now this is our sum. Okay, so the sum says calculate the area of a triangle whose sides are 18, 24 and 30 in length. Also find the length of the altitude corresponding to the smallest side. Now there is a very common question. Now here I can clearly see that it is 18, 24 and 30, means it's a scalene triangle. Okay, so if it is a scalene triangle, and no height is given. Yes, no perpendicular altitude is given. So we'll have to use Heron's formula. Now that is, what is Heron's formula? It says, first thing in Heron's formula, we need to find the semi-perimeter. Now what is semi-perimeter? If I draw the triangle, it's important to draw a rough sketch of the triangle, one side 18, one side 24 and one side 30. Now semi-perimeter is you add up all the sides and divide it by 2. That gives how much? This is 72 by 2, which is a 36. So once this value is ready, we shall be placing it in the formula. Now what is the formula? Let us see. Now in this formula we have area, that is area of the triangle, is equal to, we need a big root sign. Okay, and in this root sign we have s minus a, s minus b and s minus c. Now what is s minus a, s minus b and s minus c? S is the semi-perimeter. Okay, and then a is, you can take any one side as a, any one side as b and any one side as c. Now I'll substitute it here. So this is 36 minus 18, then it is 36 minus 24 and it is 36 minus 30. Now nobody should try to do this sum without these, without writing all this. If you are trying to do it without writing all this, you can go wrong very easily. Now here what we are going to write. So here, sometimes what people do is they will write 136, then how much is this? This is again an 18 and this is a 12 here, it's a 12 and then a 6. Now they start multiplying the full thing. They'll multiply and they'll get a huge number. Okay, they'll multiply and they'll get a huge number, and then what they will do? They'll try to find the square root of this big number. Now that is a big waste of time. Not that you are going to go wrong, you won't go wrong, but then you can go wrong in the multiplication and it takes a lot of time. So I'll teach you the shortcut to get the answer in this sum. See, first thing, 36's square root is a 6, so take it out. We are finished with the 36. Now here I have here it is 6 into 3. This is a 6 into 3, 18. Then it is a 6 into 2. Don't split it into 2's and 3's. You don't have to prime factorize it. Into 2 and then a 6. Okay. So here if I see I have two 6's. I'll take out one more 6. So this one is finished. Square root is done. Okay. 3 into 2 is a 6 and here one more 6. Okay. So one more 6 comes out. So my final answer becomes 216 centimeter square. So with no multiplication at all, very fast, very quickly we could find the answer. Okay. So this is how we use herons, and you should apply this in all your sums to get quick answers. So next is, so from every pair of two 6's I take one 6. If supposing you have a pair of two 2's, you take one 2, like that. Okay. Now the second part of the question says, find the length of the altitude corresponding to the smallest side. Length of the altitude means the 90-degree line, the perpendicular, this is the smallest side. Okay, so how do we find the altitude corresponding to the smallest side? Now what we do here is, area is equal to half base into height. We can apply this to any triangle, isn't it? So area is, now here if I put 216, because I know now that the area is 216, then half, then base here is 18. This I am considering as the base because they said the altitude corresponding to the smallest side. So here, because there can be three altitudes, one this way and one this way also, but I have to take the smallest side as the base. So into 18 and into, let me take this as an h only. Okay, now this is a small linear equation. So h is how much? H is 216 by 9. Yes, 216. So h is equal to 216 by 9. That gives me, so if I divide with a 9, I'll get 9 2s are 18. Okay, and 9 4s are 36. So my answer, this height is equal to 24 centimeters. Okay, so the altitude corresponding to the smallest side is a 24 centimeter. So here the sum says the sides of a triangle are in the ratio 5:12:13, and we have to find the area of the triangle. Okay, so the ratio of the sides is given. Now here there is one very important concept. Here I have the triangle, yes, and one side is 5, naturally so here I have the triangle, which is one side is 5, one side is 12, and the third side is a 13. If I have it like this, in that case 5:12:13 are the three sides. Now these are the ratios. Now remember, it does not mean this side is a 13 and this side is a 5 centimeter and this side is a 12, because you will have to remember, when we take ratios, we cut out the common multiple, right? Like if we have a ratio of 120 by 130, we'll cut out the 10 and then the ratio becomes 12:13. That means here also, when they are talking about ratios, some common multiple has been cut out from the original length. Okay, and only then we got a number like this. See, these numbers don't have any common multiples left between them. Now, how to convert them back to lengths? Because unless we convert them back to lengths, we cannot equate them to the perimeter, because perimeter is a proper length and these are left out factors. Yes, common factors have been cut out and left out parts of the lengths. Yeah, the left out factors of the lengths are here. So what I do is, let the common multiple be x. So if the common multiple is x, only then I can get, okay, if the common multiple is x, only then I can get, when I multiply with the common multiple, I am getting the lengths. Okay, so 13x plus 12x plus 5x. So many people don't do this, okay, and it is wrong if you are not doing it. So 150. So here it is, this is a 30x is equal to 150. Cut out this, okay, x is equal to 5. X is 5. You don't have to write a centimeter, meter over there. So X is clearly a 5. If X is a 5, in that case we have, now we have the sides. 13x side becomes 13 into 5, which is, this is 13 into 5, which is a 65. 12x becomes a 60 and 5x becomes a 25. Now I have all the sides of the triangle. These are the centimeters ones. Okay, now find the area of the triangle. So how do we find the area of this triangle? Now it is not necessary to use herons for this triangle, because if you look closely, since you are in 9th standard, I can tell you this, that this is following Pythagoras theorem clearly. So we have to keep our eyes open, and this is 13 square is 12 square plus 5 square. Note it. 169, 144, 25. So 144 plus 25 is 13. So this is following Pythagoras theorem. Since this is the longest side, this becomes the hypotenuse. So I will go straight for half base into height, because half base into height is much shorter. So half into base becomes 60 and, base becomes 25 and height is 60. Okay, so my answer becomes 750 centimeters square. So without any herons, just by being little alert, we understood that this is a right angle triangle, and so we used half base into height. Now how do we know that it's not, 13 is not the base? 13 will not be the base, because 13 is always the longest side, is always the hypotenuse. Now they are saying find the perimeter and the area of the quadrilateral. Now let's see what they have given us. They have given us one quadrilateral like this, where there is a 90 degree here, okay, and this kind of a figure. So don't try to count it as a trapezium, as any of those things. Okay, so this is the figure that they have given us. This part is a 15. So the names are A, quadrilateral A, B, C and D. So they have given us this. Now this is area of the first triangle, that is area of ADC. Okay, how much is the area of triangle ADC? Now when I start finding the area of this, I start noting one thing. Square of this is a 225, right? Square of this is a 225. Square of this is a 144 and square of this is an 81. Okay, so here 144 plus 81, how much is it? 225. So I can again see square of this is equal to sum of the squares of these two. That means I have to understand that this is a right angle triangle. I could have used herons. But then I am saying use herons only when there is no other available method to you. But as long as it is a right angle triangle, it is very much simple to use half base into height. So go for area of the triangle ADC is simple half into B into H, and since this is the longest side, this has to be the hypotenuse of the triangle. So is half into 9 into 12, which is 6. So that is a 54 centimeters square. So I get a 54 centimeters square as my area of triangle ADC. Now let's come to this part. Now they have given already this is 90 degree. So we can straight away find BC first. So BC square is 17 square minus 225 square, minus 15 square, minus 15 square, which is 289 minus 225, which is equal to a 64 BC square. Okay, so BC is equal to an 8. Yes, so this is an 8. Okay, now area of the, what is the area of this triangle? So area of this triangle, area of ACB is half into 8 into 15, right? Half base into height, and that is 4, that's a 60. 60 centimeter square. So here are my two answers. Okay, I can easily add them. So for the full quadrilateral, area is for area of the quadrilateral A B C D is 100. This is 54 plus 60, which is a 114 centimeter square. So that much for the area. Now they have also told to find the perimeter. So perimeter is nothing but the sum total of the outer boundaries. So 9 plus 12 plus 8 plus 17. Okay, so that will give me the perimeter. Perimeter of the quadrilateral is 9 plus 12 plus 8 plus 17. Okay, here also how do you add? Make this a 20 and the other one is a 26. Okay, so 20 plus 26, that gives me a 20 plus 26 gives me a 46 centimeters. Okay, so that is the perimeter. Just take them and add, and don't forget to put the centimeter over here because it is a length. Before this we had put centimeter square. So this is our next question. Area of the trapezium you have to find, and they have given us these values. We have to find the area of this trapezium. Okay, so generally we can find the area of a trapezium because they give us, we know the formula that it is half into the distance between the two parallel sides into sum of the parallel sides, sum of the lengths of the parallel sides. But here, since they have not given us the height, now we are in trouble. Now what to do? Here it requires one small construction. We'll do one construction where we'll try to make this line that I just made parallel to CB. So I'm trying, this is already parallel. These are the two parallel sides they have told. Okay, so this is, these two I have made parallel just to make a parallelogram. Now if it is a parallelogram, why did I make it? Why did I make a parallelogram at all? I made a parallelogram just to make CD is equal to EB. So EB is 60 now. Yes, EB is 60. If EB is 60, this part is a 17, isn't it? This part is a 17. Opposite sides of a parallelogram are equal. Okay, since opposite sides are parallel, we call it a parallelogram. But the property comes along with it that opposite sides of a parallelogram are equal. If opposite sides of a parallelogram are equal, this is 25, then this is also 25. Okay, if this is 25, in that case, I have one triangle here, that is triangle DAE. Yes, area of triangle DAE is how much? Now here I have no other option but to use herons. Okay, so how to use herons here? How much is my semi-perimeter? Semi-perimeter is 25 plus 26 plus 17 by 2. Okay, that gives me 40, 50, 61, 68. Yes, 68. Generally, if you don't get the semi-perimeter, this numerator part as a even number, go back and check your sum once, because mostly you will get even numbers. Not that you can't do the sum with a decimal number, but then if you get an odd number on adding the numerator, check your sum once more. Okay, so here I have, this is coming to a 68 by 2, which is a 34. So I have my semi-perimeter ready here. Now I am going to apply it to herons. So this is a long sum. So here square root, then 34. The writing part is important, minus 17, 34, minus 26, 34, minus 25. Okay, so here I have 34 and then one more 17 here. Then here how much is it? That's an 8. Okay, and then I have a 9. 34 minus 25 is a 9. Now I can see clearly that there is a 17 here. That means it is a 17 into 2. So I can take out 117. So this one done. 1 2 is left from here. Yes. And then from the 9 I take out 1 3. What am I left with? That is, I am left with a 2 from this 34 and I am left with a 4 into 2. Yeah. So my square root now becomes, this is 17 into 3 into 1 2 from this set and 1 2 from the 4. Okay, so 2 into 2. So that is 51 into 4. Yes, 51 into 4 is a 204. Yes, so that gives me 204 centimeters square. But then that is the area of the triangle only. Okay, I am yet to find the full area of this this parallelogram. I'll find, and then I am going to add it. Okay, so next is my area of this. I know the area of this is a 204. So what I'll do here is I'll draw a height, and this is h. Now remember, height is of this triangle. This is at 90 degrees. This same height is also same for here, isn't it? So height between two parallel lines, you can draw it outside or you can even draw it inside. So we have drawn it outside. We are going to use the same height for this parallelogram. So right now 204, which is the area of this triangle, is equal to half into 17 into height. Yes, half into 17 into height. Height is equal to how much then? 204 into 2 by 17. Okay, this goes by 17. I can clearly see 17 ones are 17 and 2. Yes, 17, 12 into 2, that is 24. 24 is my height. Okay, so this length becomes 24. You don't have to write the unit because it's an intermediate step. Now area of the parallelogram. Area of the parallelogram is, that is EBCD, is base into height. Now base is how much? Base is 60 clearly, and height is just now we got 24. So 6 into 4, 24, 2, that is 12 this. So this is the area of the parallelogram. Come to the area of the trapezium. Come to the area of the trapezium. 1440 plus the area of this, which is a 204. Yes, so area of this triangle we have to add. So final area of the trapezium is area of the parallelogram plus area of this. So that comes to 1644 centimeters square. This is my final answer. The area of an equilateral triangle is 36 root 3 centimeters. Find its perimeter. Okay, so for an equilateral triangle, area is root 3 by 4 into a square. And what is a? A is the side of the equilateral triangle. So 36 root 3, 4, these are basically 1 markers. So all you have to know is the formula. Cut this out. So a square is 36 into 4. A is equal to 6 into 2, which is 12. So each side of the triangle measures 12. Therefore, perimeter of the triangle is 12 into 3, because all sides of an equilateral triangle are equal, so you can multiply 36 centimeters. That is the answer. So here is the question. The base of an isosceles triangle is 16 centimeter and the area is also given as a 48 centimeters square. Isosceles triangle means these two are equal. This is the base. Okay, you have to find its perimeter. So what we can do is, supposing there is one formula, but there is no requirement to know the formula, we can make a perpendicular here. Now due to congruence, this side equal to this is 90 degree and this is the common side. So by RHS we can prove congruence between these two triangles, then this part becomes equal to this part. So now we have, so we can find the area of this, okay, since the area is given we can find the height, and since we know this is 8 now, okay, then we can find this side, then go for the perimeter. So our first job will be to find the height. So area is equal to half into base is 16 into height. Yes, this is 8. Area is a 48, 8 into h. h comes to a 6 centimeters. Okay, if this is a 6, now let me apply Pythagoras. So here let me name this as a s. So s square is 6 square plus 8 square, which is 36 plus 64, that is 100. Okay, then s is equal to square root of 100, which is a 10. Okay, so if s is equal to 10 centimeters, therefore perimeter is going to be, perimeter of the triangle, yes, perimeter is going to be 10 and 10, don't do 10 into 3 by mistake, okay, 10 into 10 plus 16, okay, so perimeter becomes 10 plus 10, 10 plus 10 plus 16, which is equal to 36 centimeters, okay. So that is it for today from this chapter. This chapter isn't a very big one. It is, these are the most important sums that I have picked up, and with the help of these you can do all the sums of these chapters, this chapter. So my next video is going to be on circles, chord properties of circle and circle theorems. Okay, so if you have liked the video, you can, do not forget to like, share and subscribe. That's it for today. Till then, goodbye.